Okay, so in this video, we're going to graph sine function. So the sine function is usually in this form. So you have some function f of x is equal to a times sine of, say, k times x plus or minus some b. And then we can add a c to it. So now here you have to remember what these components are. So a in absolute value represents the amplitude of this function, and k would give us the frequency of the sine function, and b represents the horizontal shift of the sine function, and c, of course it's the vertical shift. So this can also be plus or minus. So knowing that from transformation of functions, how do we find the period of the sine function? So the period of the sine function, let's call it a p, is given by 2 pi over the frequency k. So that would tell you how many cycle for one period, okay? And then B will tell us if the graph is shifted left or right, and C will tell us if the graph is shifted up or down, which is the vertical shift. And also there is something called the interval where the function completes one period. It's usually for the basic sine function would be from 0 to 2 pi. That's for y equals, let's say, sine of x, just the basic sine. So that's for that. But now if there is a modification with k, then your period is going to be, so for one period, it's going to be completed on the interval 0 to 2 pi over k. And if there is a shift, then of course this gets modified. You can add or subtract the horizontal shift to determine your interval for one period. So knowing that, let's take a look at our first example, see if we can apply all of these little detail. Okay, so here's our first example. So we want to find the amplitude, the period, and horizontal shift of this function, and we also want to graph it after all. So the amplitude of this function is going to be the absolute value of a, which is -6, that would be 6. So the amplitude of this function is 6. Now what about the period? Well, the period, it's going to be period equals 2 pi over k. In this case, this 5 represents the k value. So k is equal to 5. So we have 2 pi over 5. That's the period. And then there is a horizontal shift. So this, the shift of +5, so this guy right here, because it's a positive, we're going to go to the left pi over 5 units. So we're going left pi over 5 units, or we can say it's -pi over 5 is the horizontal shift. So that's the horizontal shift. Okay, so knowing that, and then we can also determine on which interval the graph completes one cycle. So let's figure that out. So we know the basic sine completes one period on the interval 0 to 2 pi. Well, our case, our period is not 2 pi, it's 2 pi over k, so it'll be 0 to 2 pi over 5. But now because it's been shifted to the left, that means we're going to subtract the shift from each x component. So we have 0 minus pi over 5, and then 2 pi over 5 minus pi over 5. That will give us the interval where the graph will complete one cycle. So that would be the interval -pi over 5, and then 2 pi over 5 minus pi over 5, that's 1 pi over 5. So there you go, that's the interval where the graph will complete one period. All right, so knowing all of this, now we're sort of ready to graph this function. So let's start off with just the sine function. So we know the graph of y equal, let's use the amplitude 6, and then sine of x. We know that graph would look something like this. So it'll start at 0, and then the height is 6. So we have 6 and negative 6. And then it goes up, comes down, and then goes back to 0. So this height is obtained at pi over 2. This is pi, and this is 2 pi. So that's what we call a 1 period. It's just 3 pi over 2. Now, we're not drawing this one. We're doing a transformation to this. So now, say we want to graph this function. Y equals 6 sine of 5x. So what that's going to do is that now the period is not going to be just 2 pi, it's 2 pi over 5. So the graph we have is just going to shrink. So we can come up with another graph. So that would be completing one cycle at 2 pi over 5. So we again start at 0, go up. So this is 6 and negative 6. Then we go up, come down, and then come down, and then go back to 0. So that's 1 period. So now the difficulty will maybe be figuring these interval out. So what you can do is you take the interval of the 1 period length, so that's 2 pi over 5, and then you divide that by 4, which will give you 2 pi over 20. So this will simplify to pi over 10. So each little interval, it's a length of pi over 10. So this is pi over 10, and then we have 2 pi over 10, that's pi over 5, and this is 3 pi over 10, and then 2 pi over 10, that's 2 pi over 5. So there you go. Those are the points on the interval. And now we're ready to do the graph that we're given, which was y equals negative 6 sine of 5 times x plus pi over 5. So we already did the half of it. Now we just need to shift all of these points to the left, pi over 5 units. And we're going to reflect about the x-axis because of the negative in front of x. Now 6, sorry. So, so we're going to draw another xy plane and then come up with a graph. So here is our xy plane. And so we have this one right here, which is a positive 6 sine of 5x, but the negative 6 will just be a reflection. So it would look something like that. So that will be the y equals 6 negative sine of 5x. So now if I want the plus pi over 5, I just shift everything to the left, pi over 5 units. So the 0 gets shifted to pi over 5 units to the left. So that would bring us right here. Let's say negative pi over 5. So that's for the 0. 0, 0. Now it's at negative pi over 5. And then pi over 10 gets shifted left, pi over 5 units. So that's going to be right here at negative pi over 10. And then pi over 5 minus pi over 5, that's going to be shifted to 0. And then we need 2 more points. So we have 3 pi over 10, which will get shifted to pi over 10. And then the last one, 2 pi over 5, shifted left pi over 5 units. This will be pi over 5. And then we just make the same shape. So we go down to negative 6, above to positive 6. So we're here, and then at 0, and then at 6, and then back to 0. So something like that would be the graph of this function. And then it continues in both directions. So now you can tell that one cycle is right here. This is 1 period of this function, which is on the interval negative pi over 5 to pi over 5. So which matches with our answer in the beginning when we said that the function will complete 1 period at this interval. So that kind of like a way to double check the answer. All right, so this is it. I hope this makes sense.